Oh, what's up, everybody? Welcome back. Today we're working on our collaborative Rube Goldberg machine. So this is what you're seeing on the screen right now. There's like this simulation running. The balls are moving through these chambers, we're calling them, and each chamber is defined by a WebAssembly module. So the idea is that the simulation as a whole, he in this top right chamber doesn't know that platforms even exist. All he knows is that he's calling into this WebAssembly module, and the WebAssembly module says, "Hey, I would like to move the ball." Right? So we apply gravity to the ball, we move it, and then we ask the chamber "Hey, is there anything you want to do?" And he says internally, he goes, "Oh yeah, I have this platform here, and I know that when the ball hits the platform, I need to push it up a little bit, right?" And so he says, "Yeah, just push the ball up a little next frame, please." And so the idea is that we can have pretty much infinitely custom behavior in each of these chambers. Right now, the chambers are really boring because we're just kind of figuring out what the API should be. But they do whatever they want, right? And so then the chambers will serialize their state, and the server sends that up to the client, as well as with the same WebAssembly module. And he asks again, "Hey, given this state, what do you want to draw on the screen?" And then the WebAssembly module says, "Oh, I'd like to draw some platforms here." And so the idea is that we want to run this large scale simulation with a lot of balls, and users will be able to upload whatever WebAssembly modules they want. I will have to approve them manually because I don't want you guys drawing shit that you shouldn't be drawing. But I'll approve them and put them into this global simulation, and we'll be able to see this fun big machine is kind of the idea. And the topic for today is trying to work a little bit further on this inner chamber ball thing. So you'll kind of notice if you look closely, when a ball goes over a border, it's never in both chambers at once. It kind of very quickly moves from one to the other when it passes halfway through, right? And that kind of sucks. Because if you had a wall in the corner of one, you kind of want that to collide and maybe prevent a ball from moving over. You probably want the ability for balls to interact with each other across the boundary, right? So I think what we want to do is we want to basically act as if a ball is in 4 chambers at once, right? If a ball sits right on the corner, we're going to basically run it through all 4 chambers and see what each chamber wants to do to it, as well as apply collision with all of the balls in all of those chambers. So that's the plan for today. I think that it will take a bit of time. If we happen to rip through that really quick, the backup plan is to work on maybe chamber rearrangement, right? So some API on the server to say, "I want to swap these 2 chambers around so that we can organize them in some way if we feel like it." Oh yeah, that's the plan. That's the plan. Not much to talk about. Just make the balls hit each other. Yeah. Thanks King Cabrams for the tier 1. Is there any test API out there yet? I mean, you can check the GitHub. You can see what we have in our simple API. It's pretty straightforward. It's we have an initialization function, a couple memory areas in the WebAssembly module that the external APIs are going to look at, as well as a save, load, step, and render. So pretty straightforward. I think that I'm not going to say that it's ready yet because I think that there's a really good chance that after I dogfood it a little bit, I'm going to want a render background and render foreground. But we'll see. So we're getting there. We're pretty close. Let's jump into trying to group balls by, whoopsies. What the fuck did I just do? I just was on the wrong thing. 0340. Group by chamber. So specifically, right now we kind of have the ability to walk through, these balls are in this chamber. But we want to know these balls are touching these chambers, which is a very slightly different concept. But I think it should be pretty straightforward. So if we go into our simulation, I'm on the wrong thing. Here, let's quit GDB. Are we in a good state? Just do a little commit-m smiley face to make sure that we don't clobber anything that we just did before stream. And we just want to make sure that, let's see. Where right now, when we apply physics to the balls within a chamber, we kind of just say, hey, we have a list of balls, and we also keep track of which chamber each ball belongs to. And so we just have to extend this concept a little bit so that when we get the balls for a given chamber, before we're going okay, let's see if the ball chamber is matching our chamber that we're looking at. If so, then we'll use it. And now we just have to say, okay, let's also append if the chamber to the left, right, up, or down is the same. So it should be Pretty straightforward. It might be a nice little cheat to get a 1 diameter gap between each panel. Then you don't have 2 panels controlling the physics at once. I think I want the 2 panels controlling the physics at once, though. I feel like that feels better. I don't want the balls to like just disappear into the nether, because like the problem with that is if you have like this kind of column here, right? A ball could fall in here and it'll just like stay here forever, right? Because it'll just like never hit anything. You could maybe like seed this area with like, you know, angled platforms or something, but I think it's just better just to put the chambers right next to each other. I think it's like very doable, very doable. And if we didn't do it, then I wouldn't have anything to do today. And so that would be a problem too. So here we just kind of want to say, ball present, we'll call it. And this will be, start with the condition we had already. But we can just say, or, well, let's kind of say ball chamber ID. We'll kind of split this out now because that's going to be a bit of a pain to type this over and over again. And let's change this I to be chamber index. Can we just chamber IDX? Because I think that'll be easier to understand. Okay, so we'll kind of start here by saying if the ball chamber ID is equal to the chamber ID, then we are chilling. Or the ball chamber ID is equal to chamber layout right. We added this pre-stream today, and I think that this will make this way simpler. Way simpler. So the chamber ID to the right, or the chamber to the left. No, wait, this isn't what we want to do. It's not just if it's the adjacent chamber. We want like if we're straddling the boundary. So we want like we'll do like is touching left chamber is going to be something along the lines of like ball is left ball how do I say this? Is touching left chamber is like ball pause X is less than ball radius. Does that make sense? So if the ball is you gotta draw it because we're too fucking stupid. So here I have a ball and we have a wall here. So this is the radius here, and this is 0. For every chamber, this is 0. Sometimes my left ball touches the right chamber. Thank you. Thank you. That is useful and helpful. So if this is the position, the X position is here in the center. And so if the position is, yeah, if it's smaller than the radius, then it is leaking into the left chamber. So the is touching right chamber is kind of like the same thing, but it's more like ball pause X plus ball radius is greater than 1.0. Yeah, and then we have the same for top and bottom. So, and I guess like probably I kind of want these to be lazily evaluated. Not that it matters, but we could split these into functions. I think I'm not going to. But that's okay. So top 0 is the ground. So this is the same as this, and then bottom is this one. Okay. Yeah. And then we can just say, or is touching left chamber and ball chamber ID okay, so the ball is in like some chamber X. And if he's touching the left chamber from there, we actually want to see if it's the right chamber from us. So we can actually, or we can say the left chamber from him is us. Yeah. Chamber layout left of the ball chamber ID is equal to us. Yeah. That feels like it makes sense to me. And so now we just say, do the same for right. Top. and bottom. And so this is like if the ball is present in our chamber. Then we can just replace this if with is ball present. Why does this say obviously not? it's not obvious to me anymore, so we'll just delete the fixing. So if the ball is present, we add the ball and then we track the original index. Right, okay, yep. Then we step the thing and we put the balls back. Okay. That seems like it might work. Let's see. So, this actually might, like, if this works, then we should be able to see balls interact on the border. We won't see them drawn on the right spot, but we'll see them maybe interact with each other. These up and down ones need the self chambers len. Items len maybe? Yep. To do the like correct vertical wrapping. Because you were catching just to return. Oh yeah. Thank you. Return error, idiot. Thank you. Hey, what's up? Okay, so let's see here now if this... Oh, okay, so I think I did see at the very bottom here, I think I am seeing physics interactions across the border. Yeah, that does look like it, huh? They're not perfect, but they're at least... Ooh, that's weird. But I think it's working to some extent. Okay, now I want to like render... How do I want to render this thing? I want to duplicate the balls so that they are rendered in both chambers. Because right now, each of these chambers is like its own HTML canvas. And I'm kind of like okay with that, to be honest. So I think what I'm going to do is I'm going to split out this code that we just wrote to like determine which ball is in which chamber. And we can use this in order to send from the server to the client which balls are in which chambers. So here we should have something like, when we get the simulation state, we right now return all the balls and which chambers the balls are in. I think still keeping like the balls here makes sense, but instead of returning which, sorry, here we have ball chambers. I think that we want to do chamber balls. So this is going to be a mapping of basically which ball indices are in which chambers. So if we have like, I think it's a double array of ball index. So if we have like chamber balls 0 is going to be a list of ball IDs that are in chamber 0. Yeah, that makes sense. And both of these are dynamic arrays. Okay. So we're going to have like chamber balls is going to be an array list of array lists. Ew. Of use sizes. Absolutely disgusting. And we're going to, at the end of this whole thing, like remove all of these things. So we're going to say for chamber balls items, item dinit. Okay. And then chamber balls dinit. Now what's a little confusing here is if we want like a double slice, I guess, like, how the fuck does that work? Because this is an array list of array lists, but we want a array list reference of array list references or something. So we're gonna have to do some sort of like conversion here after we set it all up, I guess. I guess actually we know how many chambers there are. Does that help us in some way? Can we do this instead? That seems like that might work. If we do this, then here instead of item dnit, we're going to say alloc free item. Okay. And then we're just going to have to like construct for each chamber. Yes. So we go through chamber by chamber and we say const chamber balls is equal to something here. So self server app simulation get chamber balls, and here we pass in something. We pass in something, which is the chamber ID. Okay. Then we defer. Probably this is gonna have to take in an allocator as well. Then we can say air defer self server alloc free chamber balls. This is gonna be a slice. And then we try to append chamber balls, the chamber balls. So this is, we'll call this chamber balls, I guess, just to avoid the name collision. Okay, that might work. Maybe. So this is gonna be chamber balls is chamber balls items. Okay. And then we just have to implement this get chamber balls. And I guess, oh, we have the mutex locked here, so that's good. So it's gonna be get chamber balls. I don't like the way that this mutex shit is handled. Like there's something really fucked about like external and internal mutex locking. I'm just gonna like put a fix me on here because like I really don't like this. Fix me, this mutex is locked all over the place and usage is super confusing. Because like here at get chamber balls, we don't want to lock the mutex, which is just confusing. It's just confusing. Okay, get chamber balls, we're gonna take the simulation. We are also gonna take an allocator. As well as chamber ID. Okay, and that's gonna look just very, very similar to this. It's maybe it could be exactly this. Let's see. So we go for ball, we check out the thing is here. Then we have ret is a, right now it's going to start as a std array list of chamber of ball IDs, initialized with an allocator. We're going to error defer ret.dnit. Okay, and then at the end of this, we're going to return try ret to own slice. Boom. Cool. If we write IDX here, this can be try. Boom. And this is ret now. So this gives us a bunch of ball indexes, which is great. That's exactly what we want. Exactly what we want. Which kind of indicates that over here in our step function, we should probably just call self get chamber balls. Given our allocator and the chamber IDX. And this just turns into like const original indices is equal to this self defer self alloc free original indices. This goes away. And now the chamber balls can kind of come from these indices, which is interesting. So we can say const chamber balls is equal to self alloc. And we know how many we have now, which is kind of fun. Very nice for us. Very nice for us. So this is going to be a ball ball allocator, and we're going to allocate original indices len. Yeah. And we can defer chamber balls dinit. Nope. Self alloc free chamber balls. Okay. Then all of this kind of goes away. No. And all we have to do here is just say for 0 original indices len I, we're going to say chamber balls I is equal to self balls at original indices I. Boom. Boom. Catch. This is still going to be catch return, and we'll write fix me return an error. And we'll do the same thing here, where we have, this is catch return and fix me return an error. Okay. Chill. And then back here, when we copy them back, we don't have items anywhere now. It's just all like this. Did that compile? Obviously not. Expected this, found that. So this get chamber balls needs to return a slice of usize, like we said. No field items at 98, right? Because this is no longer a array list. This is just a raw slice. Again, at 102, you can kind of like, we can head off a lot of these by going like this, like this, like this. This chamber balls is fucked up at 257 at server. Yeah, because this has to be tried probably. Okay, and then we can run this. And we can curl localhost 8000, and we look at ball simulation state. Okay, so here we have balls, and then we have chamber balls. So chamber 1 has 6, 8, 10, 7, and 19. Chamber 2 has 0, 2, 7, 18. Cool. And so do we see like duplicates if there's something straddling? Maybe, oh, we see one in these two chambers, which is good. Yeah, so we see a ball straddling, which is very good. Very good for us. 1 and 1. Oh, hey, I'm subbed. Yeah, somebody gave 10 gifties earlier. What a nice guy. What a nice guy. Okay, so now on the index side of things, when we get the state now, instead of going through ball chambers, we're trying to look at simulation state chamber balls chamber index, right? So this is this ID. Then we are trying to basically map this from ID or ID to balls. So this is going to be simulation state balls ID. Is this how you JavaScript? I think it's how you JavaScript. So we say balls for chamber is equal to this. Guys, is that right? Am I a JavaScript developer? That's pretty cool. I guess watching a ball slowly roll down an n-dimensional hill describes my entire field. You're just talking about gradient descent, right? You're a neural network engineer, I assume is what you mean if you're saying that. Okay, so I refresh here. Oh, that's funny. The simulation actually fucking died. This does not look like it's doing what I want. So this is probably ball ID 1. Earlier when we were talking about a ball straddling, this is the one. And also it's kind of weird that like, why is this, they are not intersecting with each other. I expect these to be pushing on each other. Okay, can we, at the very least, refresh? We can look at maybe refresh. Hello, refresh, enter. Fuck is going on? Okay, there we go. So we can look at a response. We expect to see. Okay, the ball 1 is in chamber 2 and 3. That's working correctly. Oh, but its position in each chamber is different. Oh, fuck me. Right. So this here's a bug. Maybe one of these should be drawn on the left side. It's probably that the reason that this isn't colliding here is because this is supposed to be drawn here. Did not expect to see JavaScript on the stream, to be honest. I think that, like, I'm becoming a bigger and bigger fan of using the browser as my UI for things. Because, like, the idea that I hate every GUI framework, just like every single one I've used, I'm not a fan of. And so, like, the idea that at the very least, I don't have to learn more than one, because every language you can spin up a shitty HTTP server, even if it's not built in the standard library, is like just a powerful concept. You can just like get up and running anywhere, right? Even if you're on like an embedded firmware device, it's gonna have network, right? And even if it doesn't have network, you could like serialize some state and then copy paste it out and then build like your own shitty little HTML visualizer on top of it. Like, it's just kind of nice. Elm NGML. NGML. What does that mean? What does nanograms per milliliter mean? That's not acronym. Did you mean National Gas Machinery Laboratory? Oh, NGMI, not gonna make it. That was really funny. True, using vanilla.js and basic HTML is perfect for that. Yeah. So there's a chance for this guy I eventually switch it out, but I think that like I don't really trust the like WASM sandboxes as much as like the browser sandbox. So I don't know if I'll ever actually end up doing it. Okay. So this concept of ball IDs is fucked. This is not how we want to implement this, because we need their positions to be relative to the chamber they're in. So the question is how do we fix that? How do we fix that? So we're going to have like ball straddling here. And we almost want to like turn this into two balls. One in chamber, we'll call this here chamber 0 and chamber 1. So we have like ball at like 0.98 in chamber 0, as well as ball at 0.02 in chamber 1. And so we want to like act on both of these things, but then tie them back to the source ID. So it's almost like your ball needs to have like a source. Like, this is almost like a ball view, right? This is like a view into a real ball, right? And so this kind of points to both of these, and you can have like ball view and then pass into chamber ID. And that will give you one of these things based off of which chamber you picked. And then in the ball view, we kind of just tie back like the original ball pointer or something. I think that's probably what I want. This is getting closer and closer to a multiple world implemented with ECS. That is, I mean, that's where this is going. Yeah. So I think that like we still also need the constraint where this ball view needs to act as if it's like a slice of balls as well, because the chamber API here, he expects like, hey, I'm just stepping this chamber with a bunch of balls, and it would be nice if we didn't have to change that, right? So you could kind of get away with something like ball view is like a this would be const WASM portal game coming soon. This does feel a lot like Portals, huh? So it's almost like you want like, this is like balls views. Balls view. Guys, don't. I'm trusting everyone in chat right now to not make the joke. Don't do it. Do not talk about viewing my balls. Don't do it. It's too easy. Chat is mature. If you guys all don't say anything, it's a fucking good day. Well, smiley faces. Okay, well, you can smile. You can smile if you want. So here we're gonna have like balls is gonna be, you know, this. Ball. We got smiley faces and dot dot dots. And then we have like source IDs is going to be like usizes. And then what's kind of odd is we have to like also track like the conversion between the source one and us, right? Yeah. How so here we know that we're at like some chamber ID for this balls view. This is like an implied chamber ID. So maybe we have like original chamber or actual chamber. Is going to be like something like this. Is this stupid? I'll refrain from using tuples for balls. Yeah, I guess like if we could get pairs in here in some way. I mean, we don't have like the concept of pair, but we could do something like const pair is a struct of A and B. And then we could have pairs of balls for sure. But I don't know if this is silly. Source chamber. It feels like a lot. Like it feels like we only need to store this for like border points. But maybe it's fine. I mean, it's not the end of the world if we have like a lot of these guys are just saying they have that they're from the chamber they expect to be from. Okay. Oh wait, source ID is the same as source chamber. No, source ID is like which. This is like which ball in global ball space, ball array. And this is which chamber unadjusted. Okay, so maybe we're going to do something like this. Ball view. And this is just going to be the adjusted is going to be a ball. Then we have the source ball ID, we'll call it. And then the chamber ID. That feels right. So adjust ball adjusted for a specific chamber. And so this is position in the new chamber. This is the original ball ID. I don't need to comment that. Yeah, I guess we do. And this is like which chamber the center of the ball started in. Also remember that you might need 4 ball views on corners. Yes. I think that's fine. So, because I think this is going to be short-lived to some extent. Okay, so now let's kind of get crazy. Let's get crazy. And we're going to use const balls view is going to be a multi-array list of ball view. The multi-array list is one of the fucking coolest. Like, this is like such like a fucking Zigism, but it's so cool. So this guy essentially, like if I have this struct ball view, which has 3 fields in it, he's going to make an array like this that has like ball here, ID here, and chamber ID here. So like this is like contiguous in memory, but now you can index. What's nice about this is now I can take this adjusted field. This is like adjusted. And I can like kind of like extract like a slice of this thing along this axis. Like you can think of it that way, right? So I can just say like if I can like point to all of the balls, all of the ball IDs, and all of the chamber IDs like independently. And it handles like the fact that like it automatically generates like the field names and stuff and like how they should be split in this like big array and shit. It's pretty cool. Pretty cool. Okay. So now this get chamber balls, I guess, returns a balls view. Reminds me of ECS components. Yeah, it's very similar, very similar. Except like you get it for free. You don't have to like pull in some like ECS framework or anything. It's just like it just works. Right, because now we can go here and we can basically say that depending on which of these conditions we hit, we're going to construct a different ball view. So let's think about this. So this is going to be a multi-array list of ball view. I guess we can call this just a balls view. Now, here we can think of it as like ball view is equal to a single ball view. Let's start by not actually fixing the bug. And we will just we will do this. We will construct a ball view using this ball index without adjusting it at all. So we'll just say adjusted is equal to balls at ball index. Ball ID is equal to ball index. And chamber ID is equal to chamber index. So we can kind of like start by getting the API of the thing that we want working, and then we can fix the bug after. And I think that'll make this easier in some way, shape, or form. Then we just say ret append ball view. I don't know if this is quite the right API, but we'll see in a second. And this is going to break all sorts of shit. Pretty cool. Can't remember seeing this in the standard library of another language. I mean, I don't know how you would do it in other languages. You need some like pretty heavy reflection. I guess like something like Python could do it, but like in Python, like why you like if you're optimizing for ECS in Python, I feel like you're like, what is it called? Taking like fixing the cart before the horse or something? Cart before horse. Something is done contrary to the natural or normally effective sequence of events. Yeah. So how do you use this in a sentence? May not an ass know when the cart draws the horse? Perfect. I mean, I guess that's what I was trying to say. Multi-array list has no function in it. As far as I know, Odin has it too. Oh, that's pretty cool. Does not have like a init function? Because does it not need an alloc? Oh, it's just kind of like assumed unmanaged, huh? Okay, that's fine. So we'll kind of do this. Which means that here we almost certainly have to pass in the allocator. I like that they named the allocator field here general purpose GPA. Like the only allocator you would use here is the GPA. It's not true. It could be any allocator, but it's fine. It's fine. Okay, so the D init now on 152. This guy needs to pass in our allocator when we D init. Does Odin have like the same like level of compile time reflection that Zig does? Okay. So somewhere in here, where is it bitching about? It's bitching at like 108. So chamber balls I is equal self balls original indices I. Oh, so now we don't actually need to do this. We already have the ball here. So we're gonna have like balls view is this, and then we want to defer a self ball or balls view deinted with the allocate that we passed in. We don't have to do this anymore. And now we just kind of say balls view get with adjusted. And I think that should do what we want. We might have to do like a slicing of it first. We want like self slice. So we want like const balls view slice is equal to balls view slice. And then I think you can say we take the slice and get adjusted. Is this right? Items adjusted. And maybe we didn't need the slice here. Items, is that, yes. So the slice is nice if you're going to be using this multiple times, you can like pre-calculate some of the offsets and stuff. But if we're only using it one time, this should be fine. But it looks like we're going to be using it below as well. So let's make the slice. Then this is for 0 in balls view slice len. Nice, okay. We have I wonder if you can do like balls view. That's fine, it's fine. Here we're going to look at the ball at here. So we're going to look at balls view slice get this index. So it's going to be const ball view. Then we iterate again. And here we're going to look at the next ball, which is going to be ball view 2 is going to be balls view slice get. Okay. Now what's kind of interesting here is this is wrong. We can't like have like a reference to the ball view. So I guess we want items. This needs to be the ball. We get the items adjusted at k, and then this is a reference to a thing in memory that we can work with. Did you set up a check step for ZLS? I'm started doing that. It's really nice. I have not. What does it do? What does it do? This is going to be balls view slice items adjusted at k as at j, I guess. So this looks like it'll all work. And then we need to go backwards. So we're going to say for balls 0 balls view slice len, we have the balls view idx, I guess. And we're going to say the thing at ball is balls view slice get the thing at balls view idx. So I wonder if we can just like iterate here. Is there an iterator API on this thing? So what like it gives you a better compile errors in the editor when you save. How does it work though? Do I need to like make like a new build target or something and then ZLS point it at the build target? Improving your ZLS experience. So here, right, so you define a new, yeah, okay, so this is exactly what I would have guessed. So what is the, so instead of installing an artifact, you check, and so then we could like disable like a bunch of our more expensive build steps, which is pretty nice. Okay, yeah, that makes a lot of sense. I'll probably do that in a pre-stream or off-stream entirely, but that does seem pretty nice because like you could just define your build to just skip all of the expensive parts. And that would be super sick. Super sick. Cool. Thanks for the advice. Thanks for the suggestion. So does this thing have like an iterator function? No. Okay. So I guess I will just iterate over by index. And we can do this. We can say the self balls at the view ball ID is equal to view adjusted. There we go. Wait, but oh yeah, that's fine. It's fine. We have to fix the like chamber tieback or whatever, but this is fine for now. This is fine for now. So that should build at least. Well, of course not. Why would I think that? I don't know why I would ever say that. It never fucking builds. 99. I got 99 compile errors, but a bitch ain't one. This has to be var probably. Expected. Okay, so it's server zig 257. We need to say that this uses this chamber balls items at adjusted. No, this is going to be ball ID, I guess. And then we have an error somewhere at 251 here. Oh, because we can't free this chamber balls now. This has to be this chamber balls dinit with self server alloc. Okay. Close, close, close. This has to be var. Okay, we're compiling again, and we shouldn't have fixed anything. We should just still be able to run. It should be run in the same shape. Wow, why is this so fucking slow? Whoa, 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 whoa. What is happening here? This is new to me. Is this a double freeze? Allocation size does not match. Oh, this is probably... I'm probably doing something fucking stupid here. I probably have to dupe this. Probably. And fix me lots of error defer leaks here. He doesn't like this for some reason. Because this has to write usize here. Okay, refresh. Okay, that's better. Now, okay, so this is still just like all broken in the exact same way as it was before. But we can fix it. We can fix it. Lots of leaks. Holy shit, lots of leaks. Look at this. Look at this number just fucking. Because at server zig 250, we need to defer this. Okay. Okay. So let's start by adjusting the API here. So instead of doing a set of balls as well as ball IDs, I think we're just going to replace this with hard-coded balls. Because I think from like from the rendering side, we don't need the like tieback of anything. We can just kind of get away with saying that like these balls have these chambers. Which means we're gonna say like I think that it makes sense here. So this guy has like these chamber balls that he's pulling out, and we kind of want to like copy paste everything out if we can. Does that make sense? Response JSON gets this thing. Here we're doing all of this under the lock of the under the mutex lock of the simulation. This get chamber balls, I believe, copies everything out that it needs to. Yeah, so this we don't have to like worry about stuff changing out from under our what's it called? Under our noses. That's the thing. So I guess that kind of means that this stuff can like we can save the content of this outside. Which kind of means that here we can just say this chamber balls whoa, where? Oh, I see. So we're gonna want like chamber balls here. This is gonna turn into holding balls views. Like this. And this just needs to become a public alias. Yes. It's all coming together. So here we kind of every chamber we append just the ball, this chamber balls here, like we were before. Error defer chamber saves pop. No, we don't have to because this gets cleaned up no matter what. So this is actually fine. This is fine. No error defer leaks because this gets DNA'd up here anyways. No big dealio. Okay, then here, instead of this calling balls as simulation balls, we have chamber balls. And this is going to be something. We need like a new slice of balls slices. So you need to do something like, we're going to call this balls views, which is kind of annoying. And then down here at the very end, I guess we're going to have like balls, chamber balls of const ball, like this. And here, these are going to be references to ball slices in balls views. Yeah. This is starting to come together. It's starting to come together. Which means that here, all we have to do is dinit this, because we are not owning the slices in here. These are owned by this guy. Which means that here we have like item dinit at with self server alloc. Okay. Does that compile? Not quite, because down here, response JSON, this needs to come from chamber balls items. That feels right. Found wanted const physics ball, found something const physics ball. Oh, fine, we can do this. Doesn't really matter. Okay, now let's just double check that I didn't fuck up the memory management here. So this is gonna, we never pushed this thing, which means that here we kind of want like chamber balls append. This chamber balls items at adjusted. Like this. Okay. Okay, so now if we refresh this thing, it's fucking broken as shit. So this is at servers like 274. Maybe this is invalid. I'm gonna comment this out. I think I'm gonna make a mistake there with like where I'm pulling the memory from. No, still fucking broken. Interesting. Wow, that's quite surprising. So I actually have some memory corruption. What did I fuck up? Oh. That would do it. That would do it. I was deleting memory that I wanted to keep around, like a fucking dumbass. Okay, so that's better. This thing is not going to work. The client isn't going to work anymore because he's not looking for the right fields, but that's okay. Let's just see if the simulation state looks okay. So here we have chamber balls. Maybe. I mean, there's a chance. There's definitely a chance. Okay, so we go back to the index.js, which I think is open here as well. So we can just close this. And Rumby will run our server here. And in here is just where we have this balls for chamber stuff. This is now just going to be simulation state, chamber, balls, this ID. And then I think everything else just kind of stays the same. This whole thing is fucking frozen as shit. Maybe. It's kind of hard to tell. What the fuck is going on here? Oh wait, we didn't actually fix anything, huh? That's right, we didn't actually fix anything. We just made the API work. So now we should actually fix it. What have we done so far as well? We should probably like write that down. So let's kind of say that this was like setting, well, yeah, grouping, get server side gets balls grouped by chamber. We definitely did that at some point, and we decided it didn't work. And we moved on to like something that was like duplicating balls for multiple chambers. And now we're moving on to adjusting ball positions in ball view. And then like fuck this stuff. I don't know what we're gonna do next. We'll kind of figure it as we go. Okay, so in our simulation, now when we create these like adjusted balls, we want to basically fix this. So if we're gonna get like the adjusted ball is switched on maybe like which direction it came from. So maybe we'll make like a source chamber. We'll see if this makes sense. It feels like it makes sense, but I'm not really sure. So the source chamber is gonna have like left, right, up, down, and current. We are going to figure out which chamber we're from based off of these conditions. So this is const source chamber. Can we do like a parse here? From ball. From what? What does this come from? From ball and chamber. Okay. I don't know. And we're gonna have like this stuff comes like in here. I don't know. We'll kind of see how it goes. Ball chambers. This is going to be ball chamber ID. Okay. And the ball itself. Okay. Okay. And then we're just going to like basically if ball chamber ID is equal to, okay, so this also has like our chamber ID. And before we do any of these conditions, we're just gonna say if the ball chamber ID is equal to the chamber ID, we immediately return. Okay. Okay. So then we can do if is touching left chamber and this. Okay, yeah. We return right. This came from the right chamber. If the ball is touching the left chamber and the left chamber, the chamber's left side is us, then it came from our right. Okay. We do the same thing here. This returns left. Okay. This is starting to come together. This feels like it's making sense. What is it? Down? So this came from below us. If its top is us, it came from below us. And if this return up. Okay. Which means that here we should be able to do like const source chamber is equal to source chamber from ball and chamber. No, we need to get the ball. Where's our ball? Ball? Chamber index? Ball chamber index. Okay. Now, this could be none of them. Right? If it's not in anything, then we return none. Okay. I guess maybe we kind of pull this out so that we don't have like name collisions. Which is fine by me. Fine by me. Self chambers items len is not valid, so we'll say num chambers like this, and then these guys get replaced with num chambers like this. Okay, and then we call this with self chambers items len. Okay. It's kind of making sense. Now we get the ball view depends, the adjusted ball. This stays the same, this stays the same, but this changes now. So we can say now that the like adjusted ball comes from source chamber. And if it's none, we continue. If it's current, we return self, or we just return the ball. If it is, the source chamber is on our left, we need to decrease the ball position. So we're gonna say const adjusted is equal to ball. This is a variable, and the adjusted x minus equals 1.0. Return. I guess we do like block here and break block adjusted. I think that makes sense. We might have it backwards, but we'll see. So down, if it came from below us, its value was high, so we just subtract. Okay. And then here, we just huck this into adjusted ball. Maybe. There's a chance. Fuck. Unused local constant. Yeah, fine. If you want to be like that. Fuck. No X in physics ball. All of these need pause. If it came from the right, would it be 1 minus X? Thinking. Let's draw it. So the ball is here. His position is 0 point something. And we want him to be 1 point something. No, I think it's not 1 minus, because his position is still like off screen. Right? If we did 1 minus X, it would mirror over this line. And we want him to actually stay like out of screen over on the right. We just want to like see the effects of the left half of him, if that makes sense. So I think it's right. But good eye. It was like worth asking for sure. Because I wasn't sure about the answer. So all of these adjustments need pause fields on them. Okay, and we can refresh and just see how fucked up it is. We're running the server twice at once, which is never good. And this is really fucked. Maybe we can like reduce the complexity of this by starting with like 2 chambers that just... This is fucking broken. We've just like totally fucking busted our physics. Because these guys are never supposed to fall through the floor like this. This is supposed to be a flat floor. But it's like, it's not like super fucking, like here, the Plinko one, they're like hitting the pegs. And here they're bouncing off the thing, and here they're staying on the platforms. So it's just like, the bottom of this is a problem. Very strange. What the fuck have we done? Okay, let's reduce the number of balls to like 5. And let's slow down the physics a lot. So we can do this by saying like we step every 16 milliseconds, and that turns into the step length over a million. Like we think that should move the simulation by this amount. And we can just kind of say we think this should move the simulation less. So I think we maybe read a 2 here. I'm not sure if that speeds it up or slows it down, but we'll see. Oh yeah, that's definitely slower. We want to go even slower. Even slower. Even slower. Okay. Ah, wait. Okay, so he's coming back in on the left side of himself, huh? Like where you can see this ball, if we watch this guy, he's going to kind of flicker right here when he comes in. But he should immediately like show up here. So I don't know like what's happening. We've just fucked something up. We fucked something up. Okay. Oh, it's when we copy the ball back. When we copy the ball back, we have to undo the adjustment. We have to undo the adjustment. So it's almost like we want to keep this in the ball view. Right? If we kind of put this here and we say like source direction, let's call this source direction. I like that better. We can kind of say here source direction. We can say relative to this is the ball, which chamber the center of the ball started in. So relative to us. Okay, so if this ball view is for chamber 1 and the ball came from the right, chamber ID is 2. If the ball came from the right, direction will be right. There, that's just to clear that up. What is the responsibility of a chamber? As in, what are the things it needs to implement? It just needs to implement basically a physics step function and a render function. It's pretty bare bones. Let's see if we can pull it up. So if we look at like Plinko, actually maybe this is, yeah, it's fine. So he implements a step function, which basically says like, I'm going to apply physics to each of these balls. So in this Plinko scenario, he calculates if a ball is in collision with a peg, and then if so, he applies some physics impulse to that thing. He has a render function that says like for each peg, I'm going to like basically set the pixels in canvas memory to these like this value. So here he kind of like iterates over them all, and he sets the pixels that are within the radius of a circle to 0 to be black. And then the other things it needs to do is it needs to supply like this load and save function. This Plinko chamber, since there is no like dynamic state, the save and load function actually does nothing. But if you had like moving platforms and stuff, then you would serialize and deserialize that here, as well as then you just say like, here are some like information about the memory in my chamber. But it's actually not much. It's like 4 functions is like really it. And then like initialize, I guess. Here. Which initializes just like whatever I need to do to make sure that like I work later. This is not too bad. I think that there's a good chance that I'm going to implement like a foreground buffer as well. So just like the render function again. But like it will be drawn after. Oh, but yeah, it's not much. It's not much. I'm trying to keep it simple. Keep it simple. Keep it safe. Fellowship of the Ring trailer. I think about this so often. I don't know, this is like so fucking burned into my brain from like when I was just like a child.
Is it secret? Is it safe?
That is it secret? Is it safe? And then they say get off the road somewhere. Here?
No one knows it's
No,
here.
not there. Not there. Maybe it was a different trailer. They all get off the road and then they all hide after, which is not the sequence of events from the movie, but it was a sequence of events in the trailer. They all get off the road. Here. Hi. Yeah, right here, here.
Get off the road!
Hi. Which, yeah, it's just like that sequence is super fucking stuck in my head forever. Like, what was that? 22 years ago or something? 23 years ago? Jesus. Anyways, that's why I said something. Is it safe? I don't even know why. Is it simple? Is it safe? It's just like nobody is going to get the reference twisting that I'm doing in my head to make that happen. Like, but in my head, like, keep it simple, keep it safe is like such a defining like phrase in my brain. Anyways, who fucking cares? What was I even trying to do? Right, so I was trying to like basically undo this. So we can say like get unadjusted. Maybe we'll do this. So we'll say that this is the adjusted ball, and this is the direction. And this is going to return a new ball. So this is just going to undo whatever we did down here. And I guess it is just like kind of inverse logic. So we say like switch direction. And if it's none, we panic. Unreachable, I guess, is fine to right here. If it's current, we return adjusted ball. If it's right, if the source directions are right, we have say adjusted ball pause x plus equals 1.0. So we say what, like var new ball is equal to adjusted ball or original. Unadjusted plus equals 1.0 and return adjusted. There you go, or unadjusted. I was thinking it would be possible to kind of merge the individual chambers into one, just have different regions of chamber-specific physics. Yeah, I mean, I can kind of see, I was thinking about that, right? You could have you could inform each chamber about like its coordinate system, but I feel like there's a chance that they could like fuck each other up. You know, I like the idea of their worlds being like completely independent, just to like isolate them. Even if like it's not really a problem, it just feels like it could be. And so, I'm just doing it like this for now. I think you're right though. There is probably some potential here. If it came from up, we add 1.0. I think down is negative. But I could be getting this wrong. I get things wrong all the time. It's kind of it's my thing. It's my thing. We get things wrong sometimes. Okay, so now when we do this, we can just say get unadjusted ball from the view adjusted with the view dot direction. We are missing the direction field in ball view somewhere. And let's see if this seems okay. Oh, that looked good. This is fucked up. Why is it taking so long for it to go between these? There's something bugged here for sure on vertical adjustments. Where is it going? It's just going to the fucking nether. So horizontal's working though. That's a good sign. Just vertical is fucked up. Vertical is fucked up. Let's double check. Gravity is negative, so down is definitely negative. Up is positive, for sure. So this saying that like when we go down, we have to subtract 1.0. That makes sense. When we go up, we have to add 1.0. That makes sense. And let's make sure that on the other side, we did it in the other direction. So I'm trying to figure out where this is done here. So here, oh, no, this is the adjusted ball again. Fuck. Where is the like ball view? Here. So if we, oh fuck, I did it again. Am I high? Get chamber balls. We return a ball view. If we came from left, if it is left of us, whoa, wait a second. Oh yeah, if we are left of the ball. Oh, do we have this backwards then? From ball and chamber. If the ball is touching the left, it came from our right. Oh no, okay, so if it came from our left, its value is big, so we subtract. If it came from our right, its value is small, so we add. If it came from below us, its value is big, because at the top of its chamber, I mean minus 1.0. Oh, but it's not 1.0. It's not 1.0. So the chambers aren't square. Chambers aren't square. That's fucked. That is fucked. So we have to like define the aspect ratio, huh? We can just make them square for now, just to see if that helps anything. So I think that doesn't actually change anything in physics. It just changes our rendering of them. So let's go over to our renderer and just make them like 400 by 400. I don't think that there's still like another physics bug here, but at least now when we see them transition, they shouldn't like disappear for a little bit. Yeah, okay, so that's working now. Now the question is why here does it not hit the floor that's supposed to be there anymore? It's actually not even hit. Oh, these it is hitting actually. This is fine. It's just when it's on the corner, it doesn't quite work. Whoa, why did you see him just like fucking like teleport upwards there? I feel like there's, okay, that's colliding okay. Yeah, oh, so this is bouncing off these and coming back into the right. Dump, 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 dump. That looks so good. That like transition here. Oh yeah, baby. Okay, we need to figure out what the fuck is going on here. This is the fucking problem. Whatever this is probably solves something else as well. So can we go back? If we go back here to basically just discarding everything that isn't current, I wonder if that fixes the problem. Let's kind of like just quickly checkpoint a little bit. And let's just kind of like here go continue. Everything is just going to come from itself. So can we do something like, maybe it makes sense to like comment this out. We'll just do non-left. Is that how you, is this valid in this language? We'll see. No. Can I do commas maybe? There we go. Let's see if like that goes back to like being, yeah, so this is actually working fine here, right? Now we have the problem where they're teleporting between again, but at least like this is working. So now we can kind of like start bisecting to see which one of these fucks it up. So here we can kind of do like this. Okay. Okay, so that's fine. So it's probably the up one that's fucking it up. So if we came from above, i.e. we hit the floor. We hit the our ball goes through the floor here. And that's for some reason changing it. Now, I don't really understand why, because it's still being rendered in both chambers. So I would think still that this chamber would see the ball in it and try to push it up. And so I don't understand why that's not happening anymore. I do not understand. Because here we iterate over all the balls, or all the chambers. For each chamber, we get the balls associated with this chamber. We step the adjusted positions, and then we copy them back in. If the thing came from below us, we subtract 1.0. If it came from above us, we add 1.0. Okay. I don't think this is it, but I'm going to swap these just to see what happens. I don't think that I should. I really don't. But that does seem to fix it. Now, I don't know if it fixes it because it's just not doing what it's supposed to do anymore. And I don't really know how to test that. But we could like think about this a little harder. So the unadjusted ball, the ball came from below us. Came from below us. Let's just double check again where like the definition of up and down here. So from ball and chamber. So we're saying if we are touching, if the ball is touching the bottom chamber and we are below it. So this is the downs, this is where up comes from. So this is our chamber, us, and the ball is kind of like here. So in this scenario, the adjusted ball should be plus 1.0, which it is. And when we unadjust it, we need to go minus 1.0. When we unadjust it, we have to go minus 1.0. Oh, which we did. So I did have it backwards. Up. This is plus, and so we go the opposite way. Okay, so then do we get left and right? Left. We did minus here, so this should actually be plus, and this should be minus, because the unadjustment has to go in the opposite direction. So here, the source direction is left. So this should have a value that's very high, 1.0. This should have a value of 1.0. And so we subtract 1.0 to make it like be negative something. Then when we unadjust it, we add it back. Yeah, okay. I just had it backwards. This is fucking confusing. I fucking hate coordinate systems, man. I get fucked by coordinate systems all the time. Like they're just so confusing. And I get it, like they're important, but do you like I feel like this has got to be like one of like the biggest source of bugs in like all code I've ever written is like just the confusion around like points of view. Okay, should we add more balls back and see and speed it up and see if it feels okay? Num balls. We can go bring this back up to like 20, and then let's bring this back up to like 1,000. We're at the right speed. Maybe we have the speed still. My monitor is so fucked that the KD logo on the bottom left is burning in, and I can even see it switch tabs. Oh, that's not good. I'm so sorry. Oh, that looks so fucking good. Oh, look at that. Look at that. That's sick. Oh, that's working so good. It's working so good. Wait, that's beautiful. That's so clean. And when it goes over the corner, I think I saw an example of it showing in like 4 chambers or 3 chambers at once. Oh, did you see that? Did you see that? That was so sick. It's soothing for some reason. It's very soothing. It's just, it feels so good. It's kind of interesting too. Having like a completely dead chamber actually is kind of nice in some way. Like this chamber in the bottom left actually like does a lot of heavy lifting, which is kind of interesting. I missed it. What was the fix? I think it was like when I think we had to put the balls back. I don't know what you missed. So like when we see the ball, like if we have these 2 chambers like this, right? The ball is technically belongs to this chamber. We subtract 1 to put it like kind of on the left side of this chamber, which then teleports it over here when we adjust the chamber ID. And then when we put it back, we had like our back and forth incorrect. So when we were in this chamber, when we put it back into this chamber, we were doing the same operation again instead of the inverse. Can we make the top right chamber's background black and the bars white? It'll look even sicker. I'm curious. You've piqued my curiosity. We can definitely do that. So if we go into the platforms zig, here we can basically mem set everything to black. And when we draw the platforms, we'll draw them as white. We will rm-r test db, zig generate a test db, and then run our thing and seed with our 4 chambers. And then we refresh this. Yeah, that looks pretty cool. That's pretty fucking sick, man. Pretty fucking sick. Okay, so I think that like I don't want these to be square. And I don't really know how to fix that. Right? Like the wrapping is kind of assuming 1.0, and I guess we just have to say that like somewhere we define a canvas height on the server side, and we use that on wrap. God, it's so sick, guys. It's so distracted. Just like when they hop over the border, I'm like, oh damn, boy. Okay, but like we need, I guess, on the server side to define what our canvas height is, and it's kind of interesting too that like the chambers probably need to know their own heights. Maybe, right? Because they need to kind of know like where to cap themselves. But I guess like, yeah, I wonder what's like valid there, right? Because like here for something like this Plinko machine, it doesn't matter, right? I could just keep drawing these forever and ever and ever and ever and ever, and I would just never have balls hit them. Now it does make sense that like in my chamber, I'm doing collision checks for every single peg. So having a limit on like where the pegs should end is probably good. But I don't really know. I guess like is that dynamic? Do we want like chamber writers to have to support different chamber heights? That doesn't really make sense. So I guess we just hard code the aspect ratio somewhere. I guess we just hard code it. And we just say the height is always going to be 0.7 or something. I've been trying to learn what OASM is, and it does, but online explanations are going over my head. Could you explain how you're using it in this project? Sure, why not? So WebAssembly is a fancy way of saying second language in the browser, right? So when you write normal C code, or whatever language you're working in, I guess not whatever language. Let's say like a compiled language, like C, C++, Rust, Zig, whatever. That generates like machine instructions. Or it generates a lot of stuff as part of the compilation process. But like the output of the compilation process is like x86 machine instructions if you're running on an x86 computer. WebAssembly is essentially like a fake computer, kind of. So instead of like outputting like x86 assembly, which is executed by your x86 CPU, it's like this like intermediate language that web browsers know how to interpret and convert into those. So like you can imagine like x86, you might have like you might have like your registers, like registers here, right? And these are like basically places where you can like store numbers, right? So you can have like 1 in here, 2 in here, 3 in here. And this could, we'll call this like R1, R2, and R3. And so like when you like, if in C, if you write like 1 plus 2, that will turn into like, you know, hand wavy, load 1 into R1, load 2 into R2, R2, add R1, R2, and then the result of this addition will be like in R1 again. And then you can like do something else with it. WebAssembly, they do the same thing, but instead this 1 plus 2 turns into like push 1, push 2, add. And the idea is that like the WebAssembly virtual machine is like, it has these instructions that say like, I'm going to like have things on a stack. And I know that this add instruction looks at the last 2 things on the stack. And then what your browser can do is like with that model, it can say, okay, so I know that if I'm adding 2 things on the stack, I can put this into R1, I can put this into R2. And so it's kind of like runtime compiling this like intermediate language back into this. And like the definition of the WebAssembly is constructed in such a way that it is very efficient for many different architectures to implement. Hand wavy. I'm kind of like glossing over details and I'm kind of like talking out my ass a little bit based off like my understanding. So don't take my like this word as gold, but it's essentially saying like JavaScript, not easily translatable into machine code. WebAssembly, easily translatable to machine code and easily constructed from lower level languages, right? So the idea is that I can write Rust, I can write Zig, I can write C, I can write C++, I can like write any language I want, compile it to WebAssembly, just like instead of like your compiler, hand wavy again. Like let's just talk about like Clang and C, right? You have like Clang, and Clang kind of generates LLVM IR, which is basically like it's kind of similar to like either of these, kind of more similar to WebAssembly in the idea that it's like a language agnostic assembly-ish language. And so like usually what happens is when you compile C, you generate some LLVM IR. LLVM takes this IR and generates like x86 machine code, right? And so now it's just like your compiler just like has another branch on here that goes like to WASM. And that generates a WASM. And you can like instantiate that in your browser now. And so like all you have to do to like add support for WebAssembly to like your different languages is like basically like swap out this backend and say like, I want to make WASM now instead of whatever. I don't really remember what the question was or what I was answering, but I hope that gave you some useful context. I know I tend to kind of drop down into like lower level than anybody asked for and maybe give a little bit too much of explanations in some ways, but this is my mental model, and so that's why this is how I fed it to you. I hope that that's useful. That was perfect. Thank you. Okay, good. Okay, what were we doing on the project? I wanted to cap the height of this thing. So I want to say like set chamber height. And I guess probably whatever we set on Plinko is like probably what I want. So I guess we can just look at what the aspect ratio was before. There's also JS to WASM that might be a good candidate for example chamber impl. No way. So the only thing that I looked briefly yesterday at Python to WASM, and I don't know what's gonna happen about like libphysics, right? So like a core component of like the model right now is that I have this physics C API where basically like programs can link against libphysics to get these functions apply ball collision and apply ball surface push of colliding. These are like very important, right? Because if we want like consistent physics between all of our chambers, we need some sort of common physics library. And so I don't know if these like WASM generators from different languages like support C bindings under the hood, because that's I don't know how else to do this other than like rewriting the physics engine in like multiple languages, and that sounds like a pain in the ass. I wonder if you could compile the C. I wonder if I could compile the WASM modules like into JavaScript or something. Like if I say like libphysics, instead of generating WASM, I just generate JavaScript. I wonder if that's possible. Because like that's how we used to do things before WASM, right? My friend was telling me about this project he did, where he used FFmpeg JS or something, a port of FFmpeg with mscript in. So it was like pre WebAssembly. You basically like took the FFmpeg code base and like compiled it to JavaScript, and he would then run FFmpeg on like client machines to like do like client side video conversion really fucking slowly. So I wonder if like that's an option. Like clearly that's like clearly there's a mapping of C functions to JavaScript, but like I'd prefer to avoid that if I can. So I mean, but like if there must like it seems like doing Python WebAssembly without C bindings would be like fucking stupid, because like Python is just a glue code for C, right? Like if we're being honest, every single Python library is just like, oh fuck, we're too slow, we better do C under the hood. And so it's like, surely that exists. Like you wouldn't, like if I say I wanted to do like NumPy, like surely if I want to use NumPy in WebAssembly, like that must be supported, or else your Python WebAssembly backend is like not useful, right? Like, so I'll look into it, and I would hope that the JavaScript side is going to do like the same thing, but we'll see. I was looking into I was looking at this. I was looking at like WebAssembly languages, like what language make WebAssembly, and I kind of saw this as like kind of like the core list, which kind of like lines up with my mental model too, that like Rust, C++, and C are like kind of like the ones. Go in WebAssembly is surprising to me. And then like there's all this stuff. So it would be cool to figure it out. It'd be cool. Wait, hold on. Awesome WebAssembly languages, stable for production use. WebAssembly. I like that it's not it's like the identity is not one of the first classes here. That's pretty crazy. Okay, what was I doing? I wanted to set the chamber height. For now we won't feed into the chambers, but we will feed it into the simulation. So I think what I'm going to do is I'm just going to say like chamber height is 0.7. And when we do our wrapping, basically all of these are going to be chamber height. Like this. Whoopsies. Like this. Like this. Like this. Yeah, I think that's all of them. So now if we just rebuild this at the same thing, we should kind of see the ball teleport to the tops of chambers, right? Like if we do this, we should kind of see them like, yeah, they're kind of like spawning here. You can kind of see that, right? Which is kind of what we want. And so then all we have to do is feed this number back to the client. So maybe we add like a you know, chamber height, which kind of creates like a chamber height, and then we have to add that here to chamber height, and I guess this is gonna be a float. Sorry, this has no parameters here, and then when we actually use it, so chamber height now, we'll just take simulation dot chamber height and kind of serialize this. So we'll do like an alloc print, I guess makes sense. So this goes simulation chamber height, and this then I guess kind of does the same thing here, where we create an HTTP writer claiming we're JSON, where the JSON just has a single number in it, like this. And then in index, maybe in a simulation renderer, here we take in the chamber height. And here we say the height is this canvas width times chamber height. Okay. Then in like index.js, we are going to like off rip just kind of ask for the chamber height. Like this. Then when we construct this, we're gonna feed in chamber height, I guess. Whatever the fuck this is. Like this. It's probably good enough. Not really sure. Not really sure. Feels right. Yeah, feels good. Yeah, that feels right. I mean, there's a little gap here in the widgets, but I'm pretty sure that's working as expected. All right, cool. I think that's like pretty good progress for the day. I think that this feels like we're like almost there in terms of like this. We need to like kind of adjust like the number of columns and stuff, but it feels pretty good. Why? Whoa, 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 whoa. What's going on here? Do you see the ball? It kind of like, oh no, I thought it was teleporting down, but it's not. When ball pushes into another one and into a different chamber. Yeah, it feels pretty good, man. Feels pretty good. Okay, cool. Yeah, pretty good progress. I'm really happy with this. So I'm gonna call it here for today. I think probably the next thing to do is work on some form of like adjustment UI, right? So I want to be able to like take a chamber and run it around. And then we also have to fix the fact that if the chambers are not a multiple of the row width, then we have like fucking problems to deal with. So probably we need to like inject empty chambers to deal with that. But yeah, we'll call it there for the day. So thanks for watching, guys. If you like what you saw, we stream most days at around 2 o'clock to 4 o'clock Pacific time for the main stream, as well as a pre-stream where we kind of cover like if we were to like leave the code base as it is right now, it would be kind of hard to maintain and like move forward and make make good progress with. So we have this like pre-stream where we do basically cleanup or small tasks that are not like titleable and thumbnailable, right? Where the focus is kind of more about like it's like kind of more laid back. Yeah, so that we start that usually around like 12:30 Pacific time. YouTube has VODs of all of the main streams organized into playlists. So if you want to check out what's back there, that's available. There's a GitHub link in the Twitch description as well, where all of the code for this thing will eventually end up. And if you want to see like archived VODs of the pre-stream, or you just want to give me money, those end up on Patreon. So that's linked in the Twitch description as well as the YouTube description. So if you want to check that out, that's available as well. What else? Like, subscribe, Twitch Prime, you know, all the usual shit. And then let's say goodbye to YouTube and Twitch. Let's find someone to raid.